Yes. Hello friends, welcome to the session. I'm discussing chapter 7 AC bridges. Okay. In the last session I given some introduction to the AC bridges and what the significance of quality factor and dissipation factor, and I given what are the different types of AC bridges also. Okay. Now from this session we will continue with in detail about each AC bridge. First I'm starting the inductance bridges. In that inductance bridges, first we'll start with Maxwell's inductance bridge. The first one is Maxwell's inductance bridge. Maxwell's inductance bridge. Yes, first to draw the bridge circuit. Okay, this is the Maxwell's inductance bridge circuit. Yes. And this is R1, this is L1, this is R2, L2, these are variable parameters, this is R4 and this is R3. Okay. This is I1, this I2, I3, I4. Okay. This node is A, B, C, D. This voltage is E1. This voltage is E3. Okay. And this voltage is E2. And this voltage is E4. This is E. This is Maxwell's inductance bridge. Okay. Throughout each bridge discussion, I will discuss like this only. First, I will draw the bridge circuit. Okay. Then, at balance, I will derive the balance equations. Balance equations means representing unknown values in terms of known values. Okay. From this, the questions are asking. They will give one bridge in the competitive exams. One bridge is given and asking what are the balance equations. Balance equations means unknown values represented as a known values. Then some values are known values are given. Some parameter is unknown is given. Calculate unknown. Okay, to solve any type of model based on this type, if any bridge is given, go for balance condition only. Product of opposite impedance, then we can answer any question. Okay, but here take any one is unknown impedance. In any one arm we are connecting unknown elements, remaining all are the known values. Take any one arm, but throughout I am taking this arm 1 is unknown. In each bridge I will consider arm 1 only is the unknown. But you take arm 2 or arm 3, any arm you can connect unknown elements, no problem. According to that we can form the bridge. But here throughout analysis I am assuming that arm 1 is unknown. In arm 1 I am connecting the unknown values. Now I want to calculate these unknown values in terms of these known values by applying the balance condition. I will represent the bridge, then I will apply the balance. Balance means product of opposite. Then I will derive the balance equations. After deriving the balance condition, I will list out some points. Those theory points are important to answer any question. To answer any theory questions, whatever the points I will list out, that is important. If you want to solve the problems based on this model, means how I am applying the balance condition, how I am simplifying those equations, that mainly concentrate. During solving of the problem, how we can apply the balance condition, how we can simplify, that concentration is important to solve any problem. Okay. Now, you see, this is Maxwell's inductance bridge, where R3, R4 is known non-reactive resistances. Known, okay, non-reactive resistances. Non-reactive resistances. Where R3, R4 is known non-reactive resistances. L2 is known non-reactive resistance, means there is no any inductance or capacitance in this arm. That's why it is a non-reactive resistances. L2 is known variable inductance. Non-variable inductance with variable resistance R2. Okay, with variable resistance R2. Variable resistance R2. Okay. L1 is unknown inductance with resistance R1. This you want to find. L1 is unknown inductance. Unknown inductance, okay, with resistance R1. With resistance R1. Okay. Now, by using this variable, what is the purpose of using variable parameters? By varying these parameters, we can bring the bridges balance. That is the purpose of using variable parameters. Sir, why you selected only R2, L2 is variable? Why not R3 is variable? Why not R4 is variable? Like that we can ask the question. The reason, later on I will explain. This type of model is also important. The questions are asking like this. In the problem, they are giving some balance equations. Then identify the variable parameters in a particular bridge. Then how to identify the variable parameters? That how to select the variable parameters at the end I will discuss. Okay, but this is R3, R4, L2 and L1. Okay, we want to find L1, R1 with respect to R3, R4 and L2. That is nothing but deriving the balance equations. Okay, throughout analysis I will assume that R1 is unknown. This is the known values. Clear? Now, first what I can do means I will apply the balance condition at balance. At balance. In every bridge I will follow the concept like this only. First at balance. Before that, you listen please. At balance condition there is no current through the detector. All these I am simplifying. All this analysis I am doing at the balance condition only. At balance means there is no current through the detector. Once there is no current through the detector means then these two arms are series and these two arms are series. Then shall you write like this, E equal to E1 plus E3. This 1 and 3 is in series. Then similarly E equal to E2 plus E4. We can also like this, write like this, E2 plus E4. Then what about I1 equal to I3? What about I2 equal to I4? These observations are important to draw the vector diagrams for a given bridge. But here I am not drawing any vector diagram. Mainly for objective point of view, this is not important. For descriptive point of view only vector diagram is important. Okay. Who are preparing for engineering service descriptive point of view only, this is important. That's why I am not concentrating. If anybody is there preparing for the engineering service descriptive point of view, how to draw the vector diagrams, that I will give the miscellaneous concepts that you refer in the miscellaneous. Okay, but in the main concepts I am not drawing any vector diagrams. Okay, who are important, who are preparing for engineering service descriptive point of view, that you refer in our miscellaneous concept in measurements. Okay, that will cover. Okay, but here not required. But this is observations are important during drawing of vector diagram. E equal to E1 plus E3. The resultant E equal to sum of these voltages or the sum of these voltage. And if the bridge is at balance condition, I1 equal to I3 or I2 equal to I4. Now tell me. We are doing at balance. At balance. First to derive the balance equations. Deriving the balance equation means representing the unknown values in terms of known values. During derivation, you concentrate how I am writing the impedance and how I am simplifying. That observations are important to solve any problem. Okay. Now, product of opposite impedance. This is a detector. This is a detector. Product of opposite impedance. This is R and L series. How to write impedance? R1 plus J omega L1. R1 plus J omega L1 into opposite resistance is R4 is equal to, this is R2, capital R2. You also take small R2. In some authors, they consider small R2 also. In some textbook, they are not considering small R2. Where small R2 is the unknown inductance, known variable inductance with variable resistance R2 and fixed resistance small r. Small R2 is fixed resistance and fixed resistance small r. Okay. If it is given, you take the fixed resistance also. Okay. Now, how to write the impedance of this? R2 plus small r2 plus fixed resistance small r2. This one. R2 plus small r2 plus J omega L2. J omega L2. Then what is the opposite resistance? R3. Then you multiply this. R1 into R4 plus J omega L1 R4 equal to S. R2 plus small r2 into R3 plus J omega L2 R3. J omega L2 R3. Now equate real and imaginary terms. Equate real and imaginary. This is the simplification. Equate real and imaginary terms. Imaginary. Equating real terms is nothing but a magnitude condition, and equating imaginary terms is nothing but a phase condition. Then what is the real terms? You tell me. Equating real terms. You tell me. This R1 into R4 equal to R1 into R4 equal to S. R2 plus small r2 into R3. R2 plus small r2 into R3. Then what is R1 equal to? R3 by R4 into R2 plus small r2. Okay, this is the measurement of unknown value in terms of known values. This equation is called balance equation. Equate imaginary terms. What is imaginary terms here? Omega L1 R4 equal to omega L2 R3. Omega L2 R3. Omega cancel. Then what is L1 equal to? L2 into R3 by R4. Okay. This is one equation. This is equation 2. This equation 1 and 2, where equation 1 and 2 is called balance equations. These are called balance equations. What do you mean by balance equations? Mean representing the unknown values in terms of known values. Like this. Every bridge we can do like this only. First represent the bridge, apply balance condition, derive the balance equation. That's over. Now from this we can list out some points that is important for theory question. If any problem is if any problem is framed based on this knowledge is important. Okay? No need to by heart this one. Don't by heart any balance equation. If any bridge is given at that, do like this, derive that one, find the unknown value. Understood? No need to by heart any balance equation. Okay. Now see, listen please. I want to list out some points. This is very important. Then whatever the balance equations we are getting, in that balance equations, is there any frequency term in the Maxwell's inductance bridge? No. But in some bridges, in the balance equations, we can get frequency term also. But in any bridge, if the balance equations does not consist of any frequency term, then we can say that balance equations are simple and easy to get the balance condition. If the balance conditions are consist of frequency, then for balance of bridge it takes more time because of frequency term. Because of frequency term, what do you mean by balance? How to bring the bridges balance? By varying the variable parameters. By varying the variable parameters, then we can fix R1 and L1 in such a way that the galvanometer shows the zero deflection, or if it is a headphones, the sound must be minimum. Then we can say that bridge is the balance. If any frequency term is present, because always supply frequency plus or minus it is changing, then whatever the value you are fixed, that value also deviating. Sometimes it is deviating. Once it is deviating means there is some minimum sound we can get. That's the reason why it takes more time to get the balance. But in the case of Maxwell's inductance bridge, is there any frequency term in the balance equations? No frequency term. That's why balance equations are independent of frequency. Balance equations are independent of frequency. Independent of frequency. Hence, easy to get the balance condition. Hence, easy to get balance condition. This one point to remember. Next, this important point. In a Maxwell's inductance bridge, the unknown inductance is measured by comparison with the known value of variable inductance. That is, these questions, based on these statements also questions are asking. That is, unknown inductance is measured. Unknown inductance is measured. Inductance is measured by comparison with known value of variable inductance. Known value of variable inductance. Variable inductance. By comparison with known value of variable. Hence, it is also called inductance comparison bridge. Hence, it is also called inductance comparison bridge. Yes, inductance comparison bridge. See the one more point. A very point important to answer theory questions. In a Maxwell's inductance bridge, sometimes the question is asking which of the following bridge is high cost and which of the following bridge is less cost. Then how to decide the given bridge is costly bridge or less cost? In any bridge, if there is a variable capacitor, then that bridge is costly bridge. In any bridge, if there is no variable capacitor, that bridge is less cost. But in inductance bridge, even you don't have fixed capacitor also. That's the reason why it is less cost. It is less cost. It is less cost. Because of absence of variable capacitor. Because of, yes, absence of variable capacitor. Variable capacitor. That's why this bridge is less cost. Next, one more point. In general, it may be AC or DC bridges. Mainly the bridges are two types. One is ratio arm bridge and product arm bridge. Then when the bridge is treated as a ratio arm bridge and when the bridge is treated as a product arm bridge. In any bridge, if the unknown and variable is exist in adjacent, then it is a ratio arm bridge. If the unknown and variable is exist in opposite, then it is a product arm bridge. But in this bridge, the unknown and variable is exist in adjacent. That's why it is a ratio arm bridge. Maxwell's inductance bridge is a ratio arm bridge. It is a ratio arm bridge. Ratio arm bridge. Because unknown and variable is exist in adjacent. Next. I told already, inductance bridges are used for measurement of quality factor. I told, more accurately measured by quality factor. Even though inductance bridges are used for measurement of quality factor, but Maxwell's inductance bridge is not used to measure the quality factor. This is important. Which of the following inductance bridge is not used to measure the quality factor? Maxwell's inductance bridge. I told already. Quality factor is measured at resonance condition. For existence of resonance, there must be inductor and capacitor. But even though this bridge is having inductance, but it does not consist of capacitor, that's why this bridge is not used to measure the quality factor. This bridge is not used to measure quality factor. To measure quality factor because of absence of capacitor. Absence of capacitor. Okay, these points you remember with respect to Maxwell's inductance bridge. This bridge is not used to measure the quality factor because of absence of capacitor. Clear? Okay. Okay, this about what exactly Maxwell's inductance. But sometimes the questions are asking like this also. They will give one bridge. In the question, it is giving one bridge. Then the bridge shown in figure represent Maxwell's inductance bridge, Maxwell's LC bridge, Hayes bridge, like Anderson bridge, like this it is asking. But by seeing the bridge, how to identify Maxwell's inductance bridge? Simply you remember like this. In any inductance bridge, if there is no capacitor, then it is a Maxwell's inductance bridge. In any inductance bridge, there is no capacitor, then it is a Maxwell's inductance bridge. If there is a parallel capacitor, Maxwell's LC bridge. If it is a series capacitor, Hayes bridge, only one capacitor. Okay. If there is 5 ohms and 5 nodes, Anderson's bridge. In any inductance bridge, if there is a 2 capacitors, then it is a Owen's bridge. Like that you remember. Just by seeing the bridge, how to identify a given bridge. In inductance bridge, no capacitor, Maxwell's inductance bridge. Parallel capacitor, only one parallel capacitor, Maxwell's LC bridge. Series capacitor, Hayes bridge. 5 ohms and 5 nodes, Anderson bridge. In any inductance bridge, if there is a 2 capacitor, then it is a Owen's bridge. But point to remember, inductance bridge consists of capacitors and inductance. But in capacitance bridges, we don't have any inductance. It consists only resistors and capacitors. Okay. Now, this about what exactly Maxwell's inductance bridge. But point to remember, how to select the variable parameters. This is important point. You write as a note. This you write as a note. Okay. In this balance equation, this equation and equation 2 are the balance equations. These two are the balance equations. What is balance equations? Means representing the unknown values in terms of the known values. In this balance equations, if R3 and R4 is selected as variables, when I select R3 and R4 is variables, the bridge never be balanced. Why? What do you mean by bridge is balanced? By varying the parameters, we can fix this R1 and L1 value in such a way that the bridge, the galvanometer shows the zero deflection. If it is a detector, it gives the minimum sound. If the detector is a headphones, we can measure as a sound, minimum sound. Okay. Now, when I select R3 and R4 is variables, now I will vary this R3, I will fix R1 value. Then sound is reduced to some minimum value. You imagine what you've done in laboratory, then you can easily understand. Okay. Then again I will vary this R4. then I want to fix L1. But already you are fixed that R1 value by varying R3. Now you are varying R4. If you vary this R4 value, already whatever the R1 you are fixed, that again changing now. Again it is deviating. Is it possible to make the bridges balance? Not possible. That's why in the above balance equation, if R3, R4 is selected as variables, the bridge never balanced. It is called divergence to balance point. If R3 and R4 is selected variables, selected as variables, the bridge never balance. The bridge never balance. Okay, it is called divergence to balance point. Okay, divergence to balance point. It is called divergence to balance point. Now, one more point. If R2 and L2 is selected as variables, R2 and L2 means the parameters which are not common is selected as a variables. Like this we can select. For example, you don't know about what is the bridge. They given the balance equations like this. In the above balance equation, which parameters are selected as variables? If the question asks like this, simply you select like this. The parameters which are not common is selected as variables. R2, in this R2 is present. In this, is it R2 is present? No. That's why R2 is variable. Here L2 is present. Is it L2 is present here? No. That's why L2 is variable. That's why the parameters which are not common is selected as variables. But this condition is applicable if the balance equation does not consist of any frequency term. Then only we can apply this method. If the balance equations are consist of frequency term means, then there is some parameters are fixed. That parameters only we can select. Okay, that means if R2 and L2 is selected as variables, selected R2 and L2 means the parameters which are not common. Okay, this point I am writing here. Okay. One more note, if R3 and if R2 and L2, one more note, if R2 and L2, that is the parameters which are not common, the parameters which are not common, selected as variables, with minimum number of steps, bridge is balance. Okay, but one more point to remember. If the selected parameters are lying on the same arm of the bridge, okay, we are selected the parameters which are not common. In some bridges, take the example of Maxwell's inductance bridge. The selected parameters may be lying on the same arm. In some bridges, the selected parameters may be different arms. That means if the selected parameters are lying on the same arm of the bridge, balance is very fast. And it is called convergence to point. Convergence to balance point. Okay, this point to remember. There is a 100% guarantee to the balance within less time. See, in Maxwell's inductance bridge, the parameter is whatever the parameters we are selected, those two parameters lying on the same arm. That's why the balance is very fast in the case of Maxwell's inductance bridge. In Anderson bridge, the selected parameters may be lying in the different arms. That's why, as compared to this bridge, the Anderson bridge takes more steps. That is the meaning. Like this we can compare. If the two parameters may be different arms, the selected parameters may be in the same arm. Understood? Okay. Like this we can make the how to select the variable parameters. Okay, clear? Okay, these points you remember to answer any theory question, and you concentrate how to derive the balance equations of a Maxwell's inductance. By seeing the Maxwell's inductance bridge, how to identify? Yes, if there is no capacitance, then is a Maxwell's inductance bridge. In any inductance bridge, there is no capacitance, Maxwell's inductance bridge. Then it is not used to measure the quality factor because of absence of capacitance, and it is a less cost because there is no variable capacitor. Particularly cost is mainly depends on variable capacitor. Sir, why you are telling that only variable capacitor is, if it is consist of variable capacitor, cost is high? Because we can design fixed capacitor, variable capacitor, we can design fixed inductor and variable inductor, we can design fixed resistance and variable resistance. But the design of variable capacitor is complex. That's why it is also costly. If any bridge consists of variable capacitor, that bridge is high cost. But here there is no any capacitor also. That's why the cost is less. Clear? So that you concern. This is the Maxwell's inductance bridge. This is one bridge in the inductance bridges. The next one you write Maxwell's LC bridge. Okay, Maxwell's LC bridge. Inductance capacitance bridge. Maxwell's LC bridge. Just simple, just you replace this by only resistance R2, just small modifications here. Then across this we can connect one capacitance. This is C4. This R4 and C4 is variables. Let this is IC4. This is IR4. Okay. Then this is Maxwell's LC bridge. Clear? Then you follow the same procedure. Yes. First, same concept. This is unknown, this is known values. Okay. Then we know that I1 equal to I3 at balance. I2 equal, this observation is important to draw the vector diagram. I2 equal to I4. What is this I4 equal to? IC4 plus IR4. IC4 plus IR4. Okay. Then what is E equal to? E1 plus E3 or E2 plus E4 or E2 plus E4. Okay. Now see, at balance. First, at balance, we can apply the balance condition. How we are writing the impedance, that you concentrate. These two are series. That's why R1 plus j omega L1. Simplification also we concentrate. These two are parallel. That is R4, product of opposite impedance. R4 into 1 by j omega C4 by R4 plus 1 by j omega C4. S is equal to R2 R3. Is equal to R2 R3. Clear? Now tell me. You simplify this, R1 plus j omega L1 into You simplify this R4 by, we get j omega C4 R4 plus 1 is equal to R2 R3. Then cross multiply R1 R4 plus j omega L1 R4 is equal to R2 R3 plus j omega R2 R3 R4 C4. Yes, equate real and imaginary terms. Equating real term is nothing but magnitude condition, and equating imaginary terms is nothing but a phase condition. Equate real and imaginary terms. Real and imaginary terms. Okay. Then what is R1 R4 equal to? R2 R3. R1 R4 equal to R2 R3. Then from this R1 equal to R2 R3 by R4. Okay, this is unknown value in terms of known value. Then equate imaginary terms. Omega L1 R4 equal to omega R2 R3 R4 C4. Omega R2 R3 R4 C4. Then omega cancel, R4 cancel. Then what is L1 equal to R2 R3 C4. This is equation 2. These equations are where equation 1 and equation 2 is called balance equations. In this, unknown inductance is measured by comparison with variable capacitance. Okay. Now you list out the points. These two are the balance equations. Same point, is there any frequency term here? No, balance equations are independent of frequency, hence easy to get the balance condition. Now unknown inductance is measured by comparison with known value of variable capacitance. Variable capacitance. Known value of variable capacitance. Hence it is also called LC bridge. Hence, inductance capacitance comparison bridge. It is also called LC comparison bridge. Inductance capacitance comparison bridge. It is high cost. Why? It consists of variable capacitor. It is costly bridge. It is high cost. It is high cost because of presence of variable capacitor. Presence of variable capacitor. Yes, it is a ratio arm bridge or product arm bridge. Now this is unknown, this is variable. This unknown and variable is exist in opposite. That's why it is a product arm bridge. It is a product arm bridge. It is product arm bridge. This bridge is used to measure the quality factor. This bridge is used to measure the quality factor. We can use this bridge to measure the quality factor. Clear? Okay. We are measuring the quality factor by using this bridge. Then what is the quality factor of unknown coil? We are measuring quality factor. Then what is the quality factor of that coil? Given coil is which coil? It is a series RL coil. This is unknown coil is series RL coil. In a series RL coil, how we can define the quality factor? Q equal to omega L1 by R1. Now I am writing this in terms of known values. Omega into what is L1 you calculated? R2 R3 C4. R2 R3 C4 by what is R1 you calculated? R2 R3 by R4. Okay. This R2 R3 cancel. What is Q equal to? Omega R4 C4. This is the quality factor of unknown coil using which bridge? Maxwell's LC bridge. Important formula. Direct formula is asking competitive exams. Okay. What is the quality factor of unknown coil using Maxwell's LC bridge? The quality factor equal to Q equal to omega R4 C4. This is a quality factor measured. Okay. By using this bridge, we are measuring the quality factor, no doubt at all. Now the question is, Is this bridge is used for high Q coils or low Q coils or medium Q coils? That is the question mark. This is very important for competitive. Okay. Then how to analyze theoretically? Is it used for high Q coils or low Q coils or medium Q coils? Tell me. If C4 is increases, if C4 is increases, what the Q is also increases, then what the cost increases. That means if you want to use this bridge for high Q coils, or if Q is increases, I am using this bridge for high Q coils, what happens? If Q is increases, then to measure the high quality factor, in this circuit, we connect the high value of C4. If C4 is increases, I told already, variable capacitor is costly, cost is increases. Hence, this bridge is not used for high Q coils, because hence this bridge is not used for high Q coils because cost is increases because of high cost. If this bridge is used for high Q coils, we want to connect the large value of C4, then cost will be increased. This is the reason why this bridge is not used for high Q coils. Then one more point to remember, this is the practical observation only. During experiment in laboratory, if you connect low Q coil in this bridge, we are using this bridge for low Q coils, the observation is it taking the more time to get the balance condition. That's why if this bridge is used for low Q coils, balance of bridge is very difficult. This is a practical observation. That's why this bridge is not used for low Q coils. If this bridge is used for low Q coils, balance of bridge is difficult. Okay, balance of bridge is difficult. Hence, this is a practical observation. Hence, it is not used for low Q coils. Low quality factor coils. Why this bridge is not preferable for high Q coils? Cost is high. Why this bridge is not preferable for low Q coils? Balance of bridge. By making some theoretical proof also there, but not required. But simply remember, this bridge is not used for low Q coils. Okay, next. It is not used for high Q coils and it is not used for medium Q. It is not used for low Q coils means then only suitability for this bridge is. Hence, this bridge is only more preferable only for medium Q coils. To measure the quality factor of medium Q coils only, this bridge is more preferable. Therefore, hence this bridge is more preferable. This bridge is used, or this bridge is more preferable for medium Q coils. More preferable for medium Q coils. Medium Q coils means what are the range of Q? For 1 less than Q, for less than or equal to 10 only, this bridge is more preferable. Okay, this is the reason why it is not used for high Q coils, why it is not used for low Q coils. If this is not used, this is only preferable for medium Q coils. Like this theoretically you can analyze. But for competitive point of view, just for remembering purpose, it is not a concept, just for remembering purpose, for objective point of view, I am telling that in Maxwell's LC bridge, which is the starting letter M, then M stands for medium, like this you remember. It is not a concept, just for remembering purpose I am telling that. Or simply remember like this, in future you don't forget. Okay, but you have the doubt, sir, in Maxwell's inductance bridge also M is there, but that is also used for medium coils. That is meaningless. I told already. Maxwell's inductance bridge is not used to measure the quality factor because it does not consist of capacitor. That's why, except that in remaining all the bridges, in Maxwell's LC bridge only M is the starting letter, then we can remember as it is used for medium Q coils. Then what is the medium Q coil range? 1 less than Q less than or equal to 10. Okay, this about what is Maxwell's inductance bridge and Maxwell's LC bridge. Maxwell's inductance and capacitance bridge and Maxwell's inductance bridge. Clear? Simply Maxwell's bridge is used for medium Q coils. But in that Maxwell's bridge, which bridge? Maxwell's LC bridge only. We don't use Maxwell's inductance bridge. That is the meaning. Maxwell's bridge. Maxwell's bridge means it may be Maxwell's inductance bridge and Maxwell's LC bridge. But in Maxwell's bridges, Maxwell's LC bridge only you can. Then by seeing the bridge, how to identify it is a Maxwell's LC bridge? I told already. No inductance, no capacitor, Maxwell's inductance bridge. Parallel capacitor, Maxwell's LC bridge. Series capacitor, Hayes bridge. 5 ohms and 5 ohms, Anderson bridge. In inductance bridge, if there is a 2 capacitor, then which bridge we can use? Which bridge? Yes, that is Owen's bridge. In inductance bridge, if there is a 2 capacitor, then it is a which bridge? Owen's bridge. Okay. In the next session, we will continue with the next bridges: Hayes bridge, Owen's bridge, and Anderson's bridge. Clear? Understand? Let you concentrate. Okay.